All right, today we're going to take a look at divisibility. In order to talk about divisibility, we kind of need to know what we mean by the word divides. So that's kind of where we're going to start. A definition for the word divides. So if A and B are whole numbers, then we say that D divides A. And it's written as this vertical bar, sort of in maybe what you would feel like is reverse notation of fractions. Okay? D, vertical bar, means divides A. If and only if there is a unique whole number Q, such that A equals DQ. If D divides A, then D is a factor or a divisor of A, and A is a multiple of D. And I'll give you numbers so it makes sense, but just jot down those details first. Okay, so we're going to use the example, just something simple, even, easy, 2 divides 6. Right? Does 2 divide 6? Yes, because it's even, right? So 2 divides 6. So we're going to use that, and we would write it like this. 2 divides 6. So we read it from left to right. We read that vertical bar as the word divides. So in some sense, you're thinking about like the fraction 6 over 2, and it ends up being a whole number. Okay, so it's sort of backwards looking from fraction notation. And this is true. This is what this is saying, is if and only if there exists a Q. In this case, Q would be 3, where 6 is equal to that number 3 times 2. So there's some number that multiplies by 2 to get back to 6. That's all of this definition is saying. There's some number. We use these words factor and divisor interchangeably. So I can't even tell you which one I use more. I have no idea. I use them both. So you'll see them both used interchangeably inside of your book, inside of your notes, every time I speak, possibly on a test. They mean the same thing. And multiple is not the same thing. It's the exact opposite, if you will. So if 2 divides 6, then 6 is a multiple of 2. That's what that's saying. So another way we could write this in words is 2 divides 6. I'll write it out. Or we can say that 6 is a multiple of 2. So we're going to start out with some properties that feel a little bit abstract, and then we'll get to some really very straightforward ones dealing with numbers today as well. So we're dealing with the abstract ones first. The first one talks about the fact that for any whole numbers A and D, if D divides A, right, like 2 divides 6, and N is any whole number, then D divides NA. Right, so if 2 divides 6, 2 is going to divide all the multiples of 6. Right, so again, the example I had done before, this is saying if 2 divides 6, then 2 will divide all multiples of 6. That's what the N times 6 mean, or N times A means. And that should make sense, right? Think about your multiples of 6. 6, 12, 18, 24, they're all even, so 2 is going to divide them too, right? And it always works that way. So if a number is divisible, then all of its multiples are divisible as well by that value. And then we're going to take a look at some comparison kind of pieces for divisibility. So if D divides A and D divides B, then D divides A plus B. Now, it works all the time, but I'll go back on these and give you examples showing, I'll do them in a different color, showing how you can see it at play and working. And there's some of these where they're not going to divide and how you can see it failing. The second one says if D divides A and D does not divide B, then D does not divide A plus B. So if it fails to divide one of them, it will fail to divide it within a sum. The third one says if D divides A and D divides B. And we have this caveat of A being greater than or equal to B, only because we're still dealing with positive numbers, not because it doesn't work for negatives, but we're just dealing with positive numbers then. So then we can say then D divides A minus B, right? Because if A is bigger than B, A minus B is positive. That's the only reason for that condition. And then we have the two pieces that are the opposites of that statement. If D divides A and D does not divide B. A is still greater than or equal to B. Then D does not divide A minus B. And because subtraction is not commutative, right, you can't switch the order around, we actually need the opposite statement about divisibility. So if D does not divide A, but D does divide B, see, we didn't have to do that before because addition is commutative, subtraction is not. So A greater than or equal to B, then D does not divide A minus B as well. So we'll see if the blue shows up and is readable enough to give you some examples. So I'm kind of making these up as we go. I think they'll all work, so it'll be okay. But we've already used 2 divides 6, so I'm probably just going to keep reusing that because we've already established that once. So if 2 divides 6, which it does, and we need 2 to divide something else, I'm going to give me another number. Another number that is divisible by 2. 4, thank you. So 2 divides 4, then we would say that 2 will divide 6 plus 4. And 6 plus 4 is 10. Does it divide by 2? Yeah. And it always will, right? You know, if you take 2 different even numbers, you add them together, you're going to get another even. So it's always going to be divisible by 2. And there's nothing special about the number 2 that does that. It works no matter what values we had used. If it meets the conditions, this will be the result. Now, let's use that same condition at the beginning. 2 divides 6, but let's choose an odd number. So 2 does not divide, say, 3. We run into a problem, right? So then when we add them together, 2 will not divide the 6 plus the 3 because 6 plus 3 makes it an odd number now. And what you might notice is that in all of these if parts, right, the premise of each of these statements, each one of them has one of them being divisible, right? Every single one. It doesn't tell you what happens if it doesn't divide the values to start with, right? It doesn't say, well, if D does not divide A and D does not divide B, then what happens? And the reason it doesn't is because it could actually result in either option. Sometimes you can add numbers together and you get something that's divisible. So, like, for example, let's say we did 2 does not divide 5. Agree? Right? 2 does not divide 3. Agree? But does 2 divide 8? It does. Now, I can't create a 2 divides example and make it the other way around, but I could do 3. So does 3 divide 4? Nope. Does 3 divide 5? Nope. But what's 4 plus 5? 9. And does 3 divide 9? Yes, it works, just like the 2 dividing the 8 worked. But does 3 divide 4? No. Does 3 divide 7? No. But what's 7 plus 4? 11. And this time 3 doesn't divide it. So you can get it to not work and you can get it to work when you change those conditions at the beginning. That's why we don't have a statement that says it always works this way, because it doesn't. It just doesn't always work this way. All right, let's do the subtraction ones. We will still use our 2 divides 6 because we can. So 2 divides 6 in this case, and we need something where it's smaller, like smaller than 6, so we can use our 4 again if you would like. So sure enough, right, my 6 is greater than or equal to my 4. So my 2 will in fact divide, and it does 6 minus 4. So 6 minus 4 is 2, it divides. It isn't so much that if I switched the order it wouldn't work, it's simply that we haven't started talking about negative numbers yet. We do that in chapter 5. So in some sense, we're just still stuck with the whole number system, is why we have that condition. And then it says, okay, well, let's disrupt the flow of things and let's make one of them not divisible. So we'll do 3. 2 divides 6. 2 does not divide 3. 6 is bigger than 3. So sure enough, 2 does not divide 6 minus 3. 6 minus 3 is 3. It's odd. And I could mess up the values on either side. So these two statements are really, the bottom two are really the same statement. They're saying it divides one and it doesn't divide the other. It's just that I have to write it twice because subtraction matters on the order that we do things, and that's the only reason this is happening. So if I switched this up and I did 2 does not divide, say 9, but 2 still divides my, I'll use 4. 2 divides my 4. Then if I do 5 minus 4, not 5, 9 minus 4, I get a 5 and it won't work, right? So it's failing to work in some cases, basically in cases where one divides and one doesn't, and it works in places where they both are divisible. But we don't actually have any statements about what happens when they're both not divisible. Okay, so we'll come back to some of this at the very end of this lesson, which is probably going to be on Friday. But we're going to look at some very specific divisibility rules first. And I'm going to try not to move my screen too quickly because I think that I've got them typed in and they'll just appear. So let's just see what we can know by thinking about these. So the divisibility rules for 2 and for 5 are grouped together because they're quite similar. So how do you know if a number is divisible by 2? I sort of just said, hey, 2 is divisible by 6, or 6 divisible by 2. You guys know that, no problem. How do you know when a number is divisible by 2? It's even. And specifically, what is it that makes a number even? What's that? You're close. I think you missed one. No, you got them all. Sorry. I didn't hear them all for some reason. Yes, you're right. Thank you, Rylan. Yeah, so it's how it ends, right? It doesn't matter about what the numbers are, like, everywhere in the value. It just matters on the ending value. It ends in a 0, 2, 4, 6, or 8. That's what I was expecting to hear. That's why it took me a second. No, you're fine. Yeah, so that's divisibility rule. We'll write it in a second for 2. What about for 5? How do you know if a number is divisible by 5? Yeah, if it ends in 5 or 0. So the divisibility rules for 2 and for 5 are similar because they both have to do with only the ending number having certain features. Does that make sense? And then the divisibility rule for 10 is the same way. What is it that makes something divisible by 10? It ends in 0. So all 3 of those rules actually are the same pattern. So it's divisible by 2 if and only if the unit's digits even, that is, it's 0, 2, 4, 6, or 8. It's divisible by 5 if it ends in a 0 or 5, and it's divisible by 10 if it ends in a 0. Okay. Have you seen those before? Thought through those before? Hopefully those are familiar. Those are ones we use quite a bit, specifically for 5s and 2s and 10s. But not all of our divisibility rules are going to be things that you're like, oh yeah, I use that all the time. They just aren't used as much. So if you flipped the page, if you've printed things out, you'll see that the next 2 rules, the ones we're going to do together, actually are 4 and 8. 4 and 8 have a similar pattern as well, kind of like 2, 5, and 10 did. They group together very nicely. And in some fashion, they're a little bit like the last 3 we did. So when we talked about divisibility by 2, I'll just use 2 for example right now. We talk about looking at the very last place value, right? One place value. Well, when we do divisibility by 4, we look at the last 2 digits instead. So instead of looking at just the last digit, the ones place, we look at the tens place and the ones place as a combined number. Not individual pieces, but as a combined number. So like if it ends in 36, we consider the number 36. And if the last 2 digits as a 2-digit number are divisible by 4, then the entire value, no matter how big it was, will also be divisible by 4. So when we looked at the number 2, we looked at the last digit. When we look at the number 4, we look at the last 2 digits. And when we look at the number 8, we look at the last 3 digits. So the last 3 digits as a 3-digit number must be divisible by 8 in order for the entire value to be divisible by 8. I promise we'll do an example of testing all these things out after we establish all of them. So 4 and 8 are similar because we're looking at the last 2 digits or 3 digits as a combined full value at the end. You might have seen the divisibility test for 3. Has anybody seen that one before? How to know if a number is divisible by 3? It's very clever.
Is it like you add the last 2 digits and it's divisible?
You're really close, Rylan. Not just the last 2 digits, but all of the digits. So in order to find out, I remember when I first learned this, I wasn't much younger than you guys were actually. It was my senior year of high school, and it was like light bulb moment, like, are you kidding me? How come nobody told me this before now? Because it's very useful, especially in my home because there were 3 children. So finding out if something was divisible by 3 was actually something, that was a regular part of my life. Okay, so you add all of the individual digits up. I don't care if there's 3 digits or if there's 2 digits or if there's 15 digits. You add them all together, and if that sum is divisible by 3, the number is divisible by 3. And what's even cooler is that nobody told me this at that point either, but what's even cooler is it works for 9s too. If you add them all together and it's divisible by 9, then the original number is divisible by 9. So the rules for 3 and for 9 are alike, right? They go hand in hand. They're just like one another. You add values together. That's not what we did with 4 and 8, and that's not what we did with 2, 5, and 10. Right? They're sort of grouping these things together in how they work. Okay, so I'm just going to flip the screen so you can write down the divisibility by 11 because there's no good way to write it or to say it, but it's not hard to do it. Okay, so just write down what's there and then I'll explain with an example what it means that we're doing. A whole number is divisible by 11 if and only if the sum of the digits in the places of even powers of 10 minus the sum of the digits in place of odd powers of 10 is divisible by 11. That's as good as it gets on a description. You can write 6 down as well if you wish, and then I'll come back and do an example for 11. 6 is really nice, and it extends beyond just the number 6, but a whole number is divisible by 6 if and only if it's divisible by 2 and 3. Which seems reasonable, but there's some caveats to it that are a little bit quirky. All right, you ready to show you what in the world number 11 was telling you? Okay, so I'm just going to make up random numbers because the process is the same no matter what numbers I pick. So please don't think that there's anything special about these values. I'm just going to write a list of numbers. So we're going to have 1, 0, 3, 2, 9, 4, 7, 2, 1. I don't know, something. Doesn't matter. Bunch of numbers. And if we want to know if this is divisible by 11, what we do is we take every other digit. So I'll highlight them in yellow. So I have 1, 3, 9, 7, and 1. These happen to be the even powers of 10. Because if you'll remember, this is the 10 to the 0's place at the end. Then I'd have 10 to the 1. But this is the 10 to the 2's place. And then I have 10 to 3. And then I have a 10 to the 3's place. I'm sorry, 4's place. And then I have 10 to the 5. Then I have 10 to the... It's the even powers of 10. So when it's talking about the even versus the odd powers, it's just talking about skipping numbers. Okay, one of them are every other number, and then the other one's the ones we just skipped. And what we do is we add those together. So if I add up 1 plus 3 plus 9 plus 7 plus 1, we want to figure out what we get. So since I made it up, I don't know, 10, fabulous, 21. And then we're going to add up everything I skipped. I'll highlight them in blue just to be clear. But we're going to add up 0, 2, 4, and 2. So 0 plus 2 plus 4 plus 2. And what do I get with this one? Somebody said it? 8. And we subtract those two values. Okay, so 21 minus 8 gives me what? 13. Is 13 divisible by 11? No. So the original number wasn't either. There's also one other thing that sometimes comes up. Like, let's say, for instance, when we added these together, they'd been the same number. So when we subtract, we get 0. Right, like they both were 21. If you subtract and you get 0, that is actually a number divisible by 11. Because 0 divides by everything except itself. 0 divides by 5, 0 divides by 7, 0 divides by 11. So if you had subtracted these and gotten a 0, it would also work, although it feels kind of funny. All right, I'm going to come back to the discussion about the divisibility for 6 if we have time at the end. But I'd like to sort of table that discussion to show you the extension for that until we have finished the other components and get there. So we're going to do an actual example where we just look at a specific number and to decide if it's divisible by these different tests that we've used or we've created. So we're doing this without a calculator. So what that means is that we're going to justify each of them by saying how we know. If it doesn't ask you to justify in your homework, you don't have to. I'm not going to count you off because the directions didn't say justify. But it can assure you that it will on a test. It will say, tell me how you know, explain why. So it might not be a bad habit to get into of making sure at least in your head you're thinking, how do I know, even if you don't write it down. Okay, so we've got the number 24,015, and we've got a list of numbers that we're testing for. Oops, and 11 over there too. And we want to know if it works to be dividing, to be divisible by. So does this divide by 2? No. Why not?
Doesn't end in a 0, 2, 4, 6, 8.
All right, so it doesn't end in an even, so I'm going to say it ends odd. Something like that. So I'm going to write justifications on these. This doesn't work. How about the number 3? How do we test for divisibility by 3? We add all the digits together. So 2 plus 4 plus 0 plus 1 plus 5. What is that sum? 12. Does 3 divide 12? Yes. So I'm going to write it that way. 3 divides 12. That's the new notation. The more I write it, the more comfortable you're going to feel with this. I'm going to try and keep pushing that. 3 divides 12. So 3 divides 24,015. So this one would be a yes. This one was no. Okay, so far so good? All right, how about 4? No. Why not?
Because the last 2 digits are 15.
Right. So 15 is the last 2 digits. 4 does not divide 15. That's that notation we learned, right? Does divide, does not divide. You put a slash through it. So 4 does not divide 20, what was my number? 24,015. Okay, how about 5? Why?
Ends in a 5.
Right. It ends in 5. 6. No, and we didn't talk about that test at length, but what am I checking for if I'm doing divisibility by 6?
Divides by 2 and 3.
Right. So does it divide by 2? No. Does it divide by 3? Yes, but they both have to be yeses, right? So this one is because 2 does not divide the 24,015. And since 2 fails to divide it, the whole thing fails. A next one was an 8. Notice we skipped 7. There is no divisibility test for 7, unfortunately. How about the number 8? Will that divide it? No. How do you know? Yeah, and the last 3 digits happen to really be a 2-digit number, right? So 8 does not divide 0, 1, 5. That's my last 3 digits. So we kind of get a freebie a little bit on that one. But check this out. The original number's not even, right? Yeah, at 24,015. It's an odd number to begin with. It's not going to be divisible by anything even. It doesn't matter if it's 2 or 6 or 12. It doesn't make any difference. The number's not even, it can't work. Now that doesn't ensure that if it were even, it would work all the time, but at least it fails very quickly because it's odd. 9, that's my next one. How do I know if something's divisible by 9? Yeah, we add them. We already did that once. So what was the sum when we did it before? 12. The sum was 12 back on step for the divisibility by 3. So does 9 divide 12? No. So 9 does not divide 12. So 9 does not divide 24,015. And our last one to test is the number 11. So, oh, I'm sorry, I skipped one. Thank you. I was just skip right over it. How about 10? Does it divide by 10? No. Why does it not divide by 10? Yes. So it does not end in 0. Now we're ready for 11. So 11 is that weird one where we just write down the numbers and we skip over pieces. So I'll do 2, 0, and 5. So what's the sum of the 2, 0, 5? 7. And then the ones that I skipped were 4 and 1. 4 plus 1 is 5. And 7 minus 5 is 2. Does 11 divide 2? No. So 11 does not divide 2, which means 11 does not divide 24,015. Now, is it a good idea to check with your calculator that these things that you just said actually are true? Sure, why not? But your calculator can't be used to justify why something works. The justification has to come from the properties themselves, okay?